Hello and good day, geometry. Today we'll be covering CO28, talking about angle bisectors. Yesterday in CO27 we talked about perpendicular bisectors, which are segments, raised lines that bisect a segment. An angle bisector, as you can probably guess, is a segment, ray, or line that bisects an angle. But just because we don't want to use the word bisect in our official definition, we will define it as a segment, ray, or line that divides an angle into two congruent sections, or two smaller congruent angles. Okay, the segment, ray, or line that divides an angle into two congruent parts. We first talked about angle bisectors, all the way back in CO6, maybe. So we've come across them before, but today we're going to go a little bit deeper into the angle bisector theorem, and then how we can use angle bisectors within triangles. So we're going to clear that and scoot on down so we can get both the theorem and its converse on the same frame here. The angle bisector theorem, similar to the perpendicular bisector theorem, I'm going to put what we know kind of in black, and then what we can conclude in red. I think I did green and red yesterday. That's okay. So angle bisector theorem. We're going to start with an angle. Okay, there you go. And if we know we have an angle bisector, that means we have a segment or ray line coming out. And then what we know in green is that those two angles are congruent. Okay, being told that that is an angle bisector, we know that those two angles are congruent. And then what we can conclude, what this theorem tells us, is that any point that is on the bisector is going to be equidistant from the sides of the angles. Okay, any point that is on the bisector is going to be equidistant from the sides of the angle, but there's a little bit of a catch. That catch being when we draw a segment from that point to the side of the angle, it needs to be perpendicular to the side of the angle. So this segment here and this segment here forming right angles there, that's important. Okay, those two segments are going to be congruent. So what an angle bisector tells us is that any point on that angle is equidistant from the sides of the angles. So segments that can be drawn from the point to the side of the angle. The catch here, though, is that they have to intersect the angle at a 90-degree angle, right? The converse of the angle bisector theorem is basically just the opposite of what we know and what we can conclude. So here's our angle again. Okay. Here is our segment, ray, or line coming out of there. And in this case, what we know, so it's going to be in green, is that we have a point that is equidistant from the sides of the angle and perpendicular to them. Okay, that's what we know. Put our markings in there as well. Therefore, what we can conclude is that because that exists, that relationship exists, then it is an angle bisector, and our two angles that are formed are congruent. Okay, so one piece of information leads you to the other, and then we flip-flop it. All right, if you know it's an angle bisector, if you know these angles are congruent, then that point, any point on the angle bisector, is going to be equidistant from the sides. That's what you can conclude. The converse says that if you know that a point on the segment, ray, line is equidistant from the sides, you can conclude it is indeed an angle bisector. Okay, what you really got to watch out for, though, in both cases here, is that you have an angle, and you've got something coming out here. You got your point there, and if you've got something like this and that, and you say they're congruent, that does not mean it's an angle bisector. Okay, those segments that come from the point must intersect the sides of the original angle at a 90-degree angle, must be perpendicular to it, right? So watch out for that. But there you have the angle bisector theorem and its converse, okay? Yesterday, we talked about the point of concurrency with 3 perpendicular bisectors. That was called the circumcenter. The point of concurrency for 3 angle bisectors within a triangle is called the incenter. The incenter. It is the point of concurrency for 3 angle bisectors in a triangle. Point of concurrency for 3 angle bisectors in a triangle. And the concurrency of angle bisectors in a triangle, that theorem tells us, try to make a non-equilateral triangle here. Okay, and by the way, the code for this video is 805. 805. You'll need that for the quiz. 805. So, drawing 3 angle bisectors here. We've got one coming out, kind of eyeballing this, doing our best. Okay, one coming out here, so we're going to mark those angles congruent. One coming out down here, and once you get these 2 in there, you can kind of eyeball the third just to intersect there because you know that they will, right? Ooh, that doesn't look very angle bisectory, but it's freehand, so we'll go with it there. And the point that's created, that point of concurrency, that in-center point, okay, it's significant. And I'm going to erase my kind of tails of these angle bisectors here. I might have to redraw some of the triangle because I don't want those hanging out there. You get confused here. But what an angle bisector, the point of concurrency tells us, that in-center tells us, that point is equidistant from the sides of the triangle. So perpendicular bisectors, the circumcenter, that was equidistant from the angles. When you're dealing with angle bisectors, that point of concurrency, called the in-center, is equidistant from the sides. But again, we have to make sure that the segments that we draw here are intersecting the sides of the triangle at a 90-degree angle. So this one's going to come straight down, intersection 90-degree angle. This one's going to go kind of up here, 90-degree angle. This one like that, 90-degree angle. You can see why I erased those other pieces of my angle bisectors. Too many lines within a triangle just gets to be really kind of confusing. But these 3 segments are all going to be congruent. Okay. Normally, here's where I ask for questions, but I just realized that no one's behind me in my classroom. So, point of concurrency, the in-center, that point is equidistant from the sides of the triangle, and those segments must intersect at 90-degree angles. So there's kind of your crash course on angle bisectors, and then how they apply within a triangle. See if you can think of a situation where an in-center would be useful. Right. Yesterday we talked about how if you wanted to put like a statue in the middle of 3 towns, each town being an angle of a triangle, since the circumcenter is equidistant from the angles, you'd want to calculate where the circumcenter is. For an in-center, why might you want a point that is equidistant from the 3 sides? Equidistant from the 3 sides. Ponder that. Think about that. See what you can come up with. Okay. Your homework is going to be a Google quiz. It is posted for you. And tomorrow we will be talking about medians. It'll be our final lesson for this week of distance learning. And we'll jump back into some more live lessons next week when you return. So that is How You Math. Don't forget to like and subscribe. Have a wonderful day. Talk to you soon.